Let's talk about finding the mean and variance of the sampling distribution of sample means. Let's have this example. Consider a population consisting of 1, 2, 3, 4, and 5. Suppose samples of size 2 are drawn from this population. What is the mean, variance, and standard deviation of the sampling distribution of sample means? So this is a combination problem. We have the population consisting of the digits 1, 2, 3, 4, and 5, and we're going to draw a sample size 2 from this population. So step 1 is to determine the number of possible combinations of sample size 2 that we can draw from these populations. So recall the formula for the combination. So capital N is the population and small n is the sample size. So here, our capital N is 5 and our small n is 2. So let us substitute the given to the formula. So that is now 5 taken 2 at a time is equal to 5 factorial over 2 factorial times 5 minus 2 factorial. So 5 factorial, it means we're going to multiply the numbers from 5 up to 1. So that is 5 times 4 times 3 times 2 times 1. 2 factorial means 2 times 1. 5 minus 2 is 3 factorial. So that is 3 times 2 times 1. So we can cancel this 3 times 2 times 1. So what's left is 5 times 4 over 2 times 1. So 5 times 4 is 20. Divided by 2 times 1 is 2. 20 divided by 2 is 10. So therefore, there are 10 possible outcomes of sample size 2 that we can draw from this population. Next, step 2 is to list all the possible samples in their corresponding means. So we're going to list all the possible samples of size 2 that we can draw from this population and their corresponding means. First combination will be 1, 2. Next is 1, 3. Next is 1, 4. Next, 1, 5. So we're done with 1. Next is 2, 3. Next, 2, 4. Next, 2, 5. Next, we have 3, 4. And 3, 5. Last is we have 4, 5. Now, we're going to get the mean of each samples. So we're going to get the mean. So we're going to get the average of each sample. So that is 1 plus 2 divided by 2. So 1 plus 2 divided by 2 is 1.5. 1 plus 3 divided by 2 is 2. 1 plus 4 divided by 5 is this. 1 plus 5 divided by 2 is 3. 2 plus 3 divided by 2 is 2.5. 2 plus 4 divided by 2 is 3. 2.5 divided by 2 is 3.5. 3 plus 4 divided by 2 is 3.5. 3 plus 5 divided by 2 is 4. 4 plus 5 divided by 2 is 4.5. Next is step 3. Construct the sampling distribution of sample means. So we need the data that we have in step 2. So these are the samples, the possible outcomes of sample size 2 that we draw from this population. So this is the mean of each samples. Now let us construct the sampling distribution of sample means. So the first column is the sample mean. Actually, this is the value of the random variable x, which is represented by the sample mean. In the second column, we're going to find the frequency of each sample mean. In the third column, we're going to get the probability of this sample mean. The sample means are 1.5, 2, 2.5, 3, 3.5, 4, and 4.5. Next is the frequency. Are we going to get the frequency? So the frequency is the number of times that each sample mean occurs in step 2. So 1.5, it occurs only once. So that is 1. 2, it occurs once. So that is the frequency is 1. 2.5 occurs twice. So the frequency is 2. 3 occurs twice. So the frequency is 2. 3.5 occurs twice. So that is 2. 4 occurs 1. So that is what the frequency is 1. And 4.5, the frequency is 1. So to find the probability of getting the sample mean is we're going to divide the frequency of each corresponding sample mean by the total number of frequencies. So we're going to add this frequency, the total number of frequency is 10. So the probability of getting 1.5 is 1 over 10. The probability of getting 2, sample mean of 2 is 1 over 10. So the probability of 2.5 is 2 over 10. Probability of 3 is 2 over 10. Probability of 3.5 is 2 over 10. Probability of 4 is 1 over 10. And probability of 4.5 is 1 over 10. Recall the two properties of the sampling distributions. So the probability must be between 0 and 1. So the probability must not be negative and must not be greater than 1. And when we add this, the sum must be equal to 1. Next step is to compute the mean of the sampling distribution of the sample mean. So are we going to do that? We're going to multiply the sample mean by the corresponding probability. And we're going to add the results. So that is 1.5 times 1 over 10 is 0.15. 2 times 1 over 10 is 0.2. 2.5 times 2 over 10 is 0.5. 3 times 2 over 10 is 0.6. 3.5 times 2 is 0.7. 4 times 1 over 10 is 0.4. 4.5 times 1 over 10 is 0.45. Then last step is to add the results. So when we add this is equal to 3. So this is the mean of the sampling distribution of sample means. Next, find the variance of the sampling distribution of sample means. So are we going to do this? So we're going to subtract the sample means from each sample mean. So remember that the mean of sample mean is equal to 3. So we're going to subtract this from each sample mean. So that is 1.5 minus 3 is negative 1.5. 2 minus 3 is negative 1. 2.5 minus 3 is negative 0.5. 3 minus 3 is 0. 3.5 minus 3 is 0.5. 4 minus 3 is 1. 4.5 minus 3 is 1.5. Next is we're going to square the difference. So we're going to multiply this twice to itself. So that is negative 1.5 times negative 1.5 is 2.25. Negative 1 squared is 1. Negative 0.5 times negative 0.5 is 0.25. So 0 squared is 0. 0.5 squared is 0.25. 1 squared is 1. 1.5 squared is 2.25. Next is we're going to multiply this by the corresponding probability. So that is 1 over 10 times 2.25 is 0.225. 1 over 10 times 1 is 0.1. 2 over 10 times 0 is 0. 2 over 10 times 0.25 is 0.05. 1 over 10 times 1 is 0.1. 1 over 10 times 2.25 is 0.225. Then the result, that is the variance of the sampling distribution of sample mean. So adding this is equal to 0.75. So the variance of the sampling distribution of sample means is 0.75. Now, to find the standard deviation, just get the square root of this. And getting the square root of this, that is equal to 0.87. So that is the standard deviation of the sampling distribution of sample means. So the sampling distribution of sample means has the following properties. 1, the mean of the sampling distribution of sample means is equal to the population mean. So meaning, if the mean of the sample means is equal to 3, then the population mean is also equal to 3. Next, the variance of the sampling distribution of sample means is given by this formula. And last one, the standard deviation of the sampling distribution of sample means is given by this. So these properties can actually ease the process of solving the mean variance and standard deviation of the sampling distribution of sample means. So meaning just using these three properties, so we can actually solve the mean, the variance, and the standard deviation of the sampling distribution of sample mean a lot easier. So let's try this in our previous example. So recall that the mean of sample means that we have computed is 3. The variance of the sample mean that we have computed is 0.75. And the standard deviation of the sample mean that we have computed is 0.87. In using the three properties, we only have 2 steps. So the first step is to compute the population mean. So to compute the population mean, just add this and divide it by 5. So that is 1 plus 2 plus 3 plus 4 plus 5 divided by 5 is 3. So the property 1 states that the mean of the sample mean is equal to the population mean. So meaning if our population mean is 3, the mean of the sample mean is also 3. Next step, compute the population variance. So compute the population variance, we're going to enumerate here our x. So the x now here are 1, 2, 3, 4, and 5. Now we're going to subtract the mean, the population mean from each random variable x. So that is 1 minus 3 is negative 2, 2 minus 3 is negative 1, 3 minus 3 is 0, 4 minus 3 is 1, 5 minus 3 is 2. Next is we're going to square the difference. So that is negative 2 squared is 4, negative 1 squared is 1, 0 squared is 0, 1 times 1 is 1, 2 times 2 is 4. Then add the results. 4 plus 1 plus 1 plus 4 is 10. Now the formula for the population variance is this. So the summation of the x minus the mean squared divided by the total number of population. So that is 10 over 5 is equal to 2. So the population variance is equal to 2. So to find the standard deviation, just get the square root of 2, and that is 1.41. So the second property, it says that the variance of the sample means is equal to this. So the population variance is equal to 2. So the sample size is 2 times the population, the total number of populations is 5, minus the sample size is 2 over 5 minus 1. So our capital N is 5, our small n is 2. So computing this, the variance of the sampling distribution of sample mean is equal to 0.75. So you will see that we get the same answer. Now, property number 3, the standard deviation of the sampling distribution of sample means is given by this. The population standard deviation is equal to square root of 2 over square root of our small n is 2 times the square root of capital N5 minus small n2 over capital N5 minus 1. So solving this, the standard deviation of the sample means is equal to 0.87. You will notice that we get exactly the same answer. So you can solve the mean, variance, and standard deviation of the sampling distribution of sample means using these three properties. Thank you.